Hey guys, so today's video is actually going to be a talk about the organization and movement of molecules in a solid versus a liquid versus a gas. So, to start us off, I do want to show you a quick video and kind of walk you through what those structures are going to look like. We're not going to watch the entire video. I just want to kind of give you a guide. Okay, so if you guys can look down here in the corner, I just have a quick picture, right? So here is an example of if I had an ice cube, right? Ice cubes are obviously solid, and I put it into a container, right? The container itself would not cause the solid to change shape, right? And the molecules in the solid, if you look down here, the molecules are actually very organized, right? And it doesn't matter if they are cold or if they are hot, they're going to stay in that structure. They're going to stay organized. That's the whole purpose of the molecules in a solid. They are going to stay the same. However, if I had a brick, which is obviously a solid, right? And I put it outside in the summertime, right? On concrete or on a blacktop, right? Where it gets really hot. Those molecules, even though they're staying in the structure, they're not moving, they're still side by side because they are hot, right? That temperature, they will start vibrating really, really, really fast. That's their energy. So when we say the molecules are moving, right, we're actually talking about the vibration. Okay, this is their kinetic energy. When they are moving really fast, right, they're hot. And then that same brick, if it's still sitting outside in the wintertime, those molecules are still side by side because they're a solid. But instead of moving really fast and having lots of energy, they are barely vibrating because they're really cold. Okay, they're still moving, right? All the molecules have energy. All molecules, even if they're super cold, have energy, have some kind of vibration. Okay. So that's kind of what you're going to see and think about when you think about a solid. Okay. A liquid's a little bit different. So liquids I compare to like kinetic sand or I don't know, Dippin' Dots or those little magnetic spheres that kids buy, and you can kind of move them around. So there's still an attraction there, right? But they can move all around, all right? Um, so if I do pour it into a container, obviously it's not going to stay in a shape, right? It's going to take the shape of the container. So if I pour it in a really long, flat, like serving dish, the liquid's going to spread out flat, right? If I put it in some kind of cylinder, right, to measure, it's going to take the shape of that container. Okay, the molecules are still stuck together, but they have the ability to move around. And again, doesn't matter if they're hot or cold, right? We've all had hot liquids, right? There's soup, there's coffee. We've also had cold liquids. So it's not the temperature that makes it a liquid, okay? So these molecules can move all around. If they are moving all around one another and they're cold, they're doing that while they're vibrating. Okay, there's slow vibrations there. However, if you put the water on the stove to like make mac and cheese or ramen noodles, that liquid is still moving around. The molecules are still attracted, but instead of vibrating slowly, they're vibrating really fast. Okay. So, again, when we talk about the energy in molecules, we're talking about how much they vibrate as they're moving around in a liquid. Now, if we talk about a gas, right? Gases are totally different. So, gases, if you look down here, gases, those molecules don't have that attraction anymore. Instead, they're kind of free floating, right? And they definitely spread out. Okay. So you can have hot gas or cold gas. Think about being outside, right? In the wintertime, it's freezing cold air outside, right? So those molecules, even though they're floating around all willy nilly, they still have a little bit of vibrating, right? They still have a little bit of energy. And then as Missouri is in the summertime, right? We have like horribly hot weather sometimes. Well, those molecules are still free floating around out there in the air, right? But they are vibrating really, really fast as they are doing it. Okay. So we have a lot of energy. So When we talk about the energy of molecules or the arrangement of molecules, they go hand in hand, but they're also kind of separate, right? It's not like every solid is cold and every liquid is a little bit warmer and every gas out there is super hot. That is not what is always making it a solid, a liquid, and a gas, because we do realize that there is cold air out there. Not all gas is hot, right? So they do have properties just simply because they're a solid or a liquid or a gas, right? And then the energy, the vibration of those molecules is the temperature. Cool.